A lot of biologists have argued that oxidative stress is at the root, the core of the problem of obesity, diabetes, cancer, and heart disease. That's not quite right. You have to take a step back. Oxidative stress doesn't come from nowhere. It comes from excess electrons. In journalistic science, you follow the money. In redox biology, you follow the electrons. Reductive stress is a buildup of something called NADH. When we eat food, the calories that come in are really just energized electrons. And those electrons in our mitochondria flow to a molecule called NADH. And then NADH can use those electrons for one of three things. Either it can hand them to the mitochondrial electron transport chain and we can turn them into ATP. ATP is the energy that we use to move our muscles and everything else that the body does. The other thing that those electrons from NADH can do, which are ultimately electrons from your food, is it can drive our antioxidant defense system. Antioxidants are electron donors. NADH can give those electrons to the antioxidants that they can donate to free radicals to eliminate them. The last thing that NADH can do is it can actually use those electrons to generate superoxide and to generate free radicals and reactive oxygen species, because electron donors, if they donate that electron to oxygen, the oxygen becomes a free radical itself, superoxide. And so that's the double-edged sword that is true of all antioxidants. If they give their electron, if they donate that electron to a free radical, it's neutralized. If they donate that electron to oxygen, it creates another free radical. Rising NADH levels act as a switch. And what that switch does is it changes from NADH using those electrons to create ATP and to use those electrons as antioxidant defense, and it shifts the balance towards using those electrons to generate more free radicals and to generate more superoxide, using fewer of them to make ATP and fewer of them in antioxidant defense. So in the rest of this video, we're going to go inside the mitochondria, which I've drawn on the back wall here, and we're going to see exactly how NADH flips that switch from using the electrons from our food for good to using the electrons from our food to create oxidative stress. I'm Brad Marshall, author of FireInABottle.net. I'm obsessed with metabolic science, redox biology, and how those things play into obesity, diabetes, cancer, heart disease. Follow along at the blog or on this YouTube channel, Fire in a Bottle. Please subscribe, it helps me out. You can also follow along on Twitter at fire_bottle or on Instagram at fire_in-a-bottle. Thanks for watching. So now we're inside of an actual mitochondria. All of our foods, so beta oxidation is the process by which we break down fats, and carbohydrates are broken down to pyruvate before entering the mitochondria, and pyruvate dehydrogenase makes pyruvate into acetyl-CoA, and beta oxidation makes fats into acetyl-CoA. So all of our food becomes acetyl-CoA. Now, that acetyl-CoA is oxidized in something called the TCA cycle, and as you can see, every acetyl-CoA group takes 3 NAD plus and converts them to 3 NADH. And this NADH comes up here to complex 1 and it gets oxidized back to NAD plus and it hands its electron off, and these electrons are used to pump protons, and when those protons come back down through into the mitochondrial matrix, ADP is converted to ATP. And so this is the source of 95% of the ATP in your body, is this electron transport chain in the mitochondria. It's how we make energy. Over here, this is NNT. This is what I call complex 6. No one else calls it complex 6, but I do. What complex 6 does is it takes these electrons from NADH and oxidizing the NADH back to NAD+, but those electrons are handed to NADP+, turning it into NADPH. Now, NADPH is what the enzyme glutathione reductase uses to create reduced glutathione, and reduced glutathione is exactly what is needed to eliminate hydrogen peroxide and convert it harmlessly back to water. And so the buildup of reactive oxygen species, you can see reactive oxygen species are created by pyruvate dehydrogenase. They're created at complex 1. They're created at complex 3. So as our metabolism goes, we're creating these ROS all over, and they're mostly eliminated by glutathione, the glutathione cycle. The glutathione cycle requires NADPH, and that NADPH is resupplied by NADH from our food. So in a healthy metabolism, you're generating hydrogen peroxide at pyruvate dehydrogenase, you're generating hydrogen peroxide at complex 1, you're generating hydrogen peroxide at complex 2, but NNT is here taking some of this NADH, turning it into NADPH, and using that for antioxidant defense. And so if that's happening, if you're making a lot of ROS, and if you're eliminating it here, it means you have a high metabolic rate. It means you're doing thermogenesis, which means that you're just burning extra calories because, like I say, the calories are just these electrons. And so the more electrons that you kind of blow off here, the more electrons that are used in this process of thermogenesis and eliminating the ROS. See, we're using electrons here and here. We're burning NADH both times. And so this process of generating and eliminating reactive oxygen species is a way of increasing our metabolic rate. But what happens in reductive stress? What happens is, and I'll talk more on other videos about how reductive stress starts in the first place. But when NADH builds up too much, what happens is this TCA cycle slows down. When this slows down, you have a buildup of acetyl-CoA. And acetyl-CoA is actually used when acetyl-CoA builds up to too high levels. It, quote, acetylates mitochondrial enzymes. So this acetyl-CoA group will literally just stick to complex 1 and stick to NNT and prevent them from working. And so that's a buildup of acetyl groups, and there's an enzyme that will remove these acetyl groups from complex 1 and NNT and make them functional again, except that enzyme is called SIRT3, and that enzyme is directly inhibited by NADH. So if you have high NADH, that means SIRT3, the thing that takes acetyl group off, won't be working. Acetyl groups will build up, and these mitochondrial enzymes will become acetylated. In obese humans, you have about half of the complex 1 activity as in lean humans because complex 1 is acetylated. And the way to get it deacetylated is to eliminate a bunch of this NADH. Now, what happens? So the problem with reductive stress, like I say, is too much NADH, too much acetyl-CoA, and acetylated enzymes. So what happens in that scenario? Well, the more NADH that you have, the more hydrogen peroxide you generate at complex 1. A paper that I just referenced in my last post stated that hydrogen peroxide levels generated at complex 1 are, quote, steeply dependent on NADH levels. NADH, they have those electrons and they have to give them to someone. And as those levels rise, there's more NADH trying to give up their electrons. If complex 1 is acetylated, they can't pass the electrons into the electron transport chain. And so a lot of those electrons start going through this alternate pathway of just creating reactive oxygen species. And so the higher that NADH levels go, the more reactive oxygen species you have produced at complex 1. If we look back at NNT, if this is acetylated, if NNT can't use NADH to generate NADPH, then what happens is this glutathione cycle is not going to function effectively because every molecule of hydrogen peroxide, you need another NADPH to deal with. And the source of that NADPH is NADH. And if NNT complex 6 is acetylated, you can't regenerate NADPH. And so as NADH levels rise, as acetyl-CoA levels rise, you have more hydrogen peroxide generation at complex 1. You have less hydrogen peroxide removal at NNT, complex 6. The glutathione cycle slows down and hydrogen peroxide levels start to build. And that is oxidative stress, is a buildup of hydrogen peroxide levels. And it's caused by mitochondrial enzyme acetylation at Complex 1 and at NNT, and ensuing build in acetyl-CoA levels and NADH. Bulksupplements.com is a great place to get any supplements that you need. If you use my discount code FIRE, F-I-R-E, you can get 12% off anything at bulksupplements.com. Also, on my blog, fireinabottle.net, click the shop button, and I've got all kinds of metabolic enhancement products. Using my discount code, shopping on the blog just helps me to keep this channel going and helps me to keep putting out great content for you guys. I appreciate it.